Okay, welcome back everyone. So today is just a quick continuation of it's just a follow-up video of the last video where we are just about to provide more intuition behind why we can just plug any value into C1 and C2 and receive any vector v, for example, in return. So if you give me any vector v, in return I just have to plug in the weights of plug in the weights of x2 and x1. So as a result, if you give me that vector, I just need those weights, and I'll give you value for C1 and C2 in return. So this is just basically another proof and another way of solving for the vector combinations, the scalars in the vector combinations, right? First of all, I just kind of wanted to give you guys a bit of physics intuition. So, obviously, vectors are very important concepts in physics, and there are things called the unit vectors. So, like, for example, I hat, and for example, j hat, right? J hat, I hat, and j hat. Those are the primary unit vectors within. Obviously, the primary unit vectors, the only unit vectors in 2D spaces. There's also z hat, if you will, but it's actually k hat. It would be more formal way in Cartesian coordinates, and these are just unit vectors. So I hat is solely an x coordinate, and these are just form a basis. And a basis has a formal definition, and I'll give you that definition in future episodes. So I hat is just basically the vector, I hat is just the vector 1, 0, while j hat is the vector 0, 1, and they are perpendicular to each other. So this can be considered I hat, and this is j hat. And again, adding those two multiplied by any constant C1, C2, you'll get all points on this graph, 2D graph in R2. So just wanted to show you that, guys, for a second. But now let's actually get on with the more important bit of the video. And no, I'm not saying physics is unimportant. By the way, I'm just using this so I can save paper. I don't know I forgot when we did that. I think this is actually, yeah, linear transformations. Okay, so let's just write down our new a vector that we had last time, which is -4, -4, 6, and b vector b5, 8. The numbers I picked here, by the way, makes this a little bit harder for me, but it'll work in the long run. So how do we do this? Well, basically, we just want to find an algebraic relationship between these two guys. So first of all, let's make a few statements, okay? So let's say we can say, if we consider this as, let's rewrite this a bit. So let's put this in the form of linear combinations. So any C1 times vector A times C2 times vector B is equal to some vector x1, x2. We'll call that the x vector. Should have just, I'm messing up my table. So we have that. Let's rewrite this a bit so it's more clear. My statement will be more clear. C1 times A, so that's -4, 6, plus C2 times 5, 8, right? Equals x1, x2, right? So that's our statement here. Let's actually make some statements. So according to this this representation of these linear combinations, we can officially say that our first value x1 is equal to -4 times C1 plus, right? Just using the basic definition of scalar multiplication, plus C2 times plus 5 times C2, right? And that's equal to x1 here. Okay, so we want to write out our statements very clearly. then here as well. And we can say our second vector x is equal to 6 times c1 plus 8 times c2, obviously, and then that's equal to x2, right? So we can officially say those two things. And if you remember this from Algebra 2, is that we can actually find a relationship that since these two statements are related, we're allowed to add both of these equations together, and we're going to be able to cancel terms and thus get our answer for both of these. So we can solve for C1 and solve for C2. It's like solving a system of equations, basically. And this, again, starts relating to the system of equations idea. Or we can actually solve this using a matrix. We can, right? Yeah, of course we can. It's pretty cool. Anyway, so let's use our way. So what we have to start with is, I want to start with solving for C2. So we want to multiply this entire equation by 1.5 in order to get this to negative 6c1, and thus we can cancel this term here, and we're left with this here, and we'll see what we get. So we can rewrite this as, rewrite this as negative 6c1 plus, I believe it's 7.5 c2 equals 1.5 x1, right? So now let's add these two equations to cancel these terms. So we get 0c1, that's just 0. We get 15.5 c2 equals 1.5 c1 plus c2, right? And that's all it is. And now to actually solve for c2, it might not be as nice as it could be, but all c2 is now that we figured it out, c2 is equal to this, right? I'm just rewriting this a bit, multiplying both the top and bottom by 10, so we can not get rid of this ugly decimal, times 1.5 x1 plus x2. You could distribute the terms if you like, but this is a decently simple way. So now we know, oops. So we have the first term of, we have C2, right? So the beautiful thing about this is that if someone was, for example, I don't know, they could be skeptical, right? So we give them a condition that we can figure out any value for C2 and C1, given that you give me x1 and x2, these values of x. So some vector, if you give me this x vector, right, then I'll figure out using this algorithm and another one for C1, which we're about to find. I'll be able to calculate the values of C2 and C1 that satisfy that. So let's do C1 now. So now I shouldn't have gotten rid of this. Oh well. Because we don't want to cancel C1. So, well, I'm gonna just rewrite these two algorithms here. Negative 4c1 plus, just rewriting things, equals x1, and then 6c1 plus 8c2 equals x2, right? So now what we want to do is we want to cancel these two terms, right, in order to solve for C1. So let's see, what can you multiply by that to get to that? I think it's 1.6, if I'm not mistaken. We can just test that out real quick. Yeah, 1.6, got it. So we just multiply this section by entire equation by 1.6, negative 1.6, because we want this to cancel. So let's do that. Negative 1.6, right? So let's solve for that. What we get our new equation. So negative 4 times that. What would that be? Well, we'll get a positive answer, obviously. So 6.4, we'll get 6.4 C1, right? And then these terms cancel, equals, we'll get x2 minus 1.6 x1, right? So now same process, we divide both sides by 6.4, and we'll make our answer a little nicer. We will actually get C1 is equal to, see if we should be able to actually simplify that a bit. Oh, it's fine. I'm just not going to worry about distributing the terms. It's equal to 64 over 10 times x2 minus 1.6 x1, right? And that is, we just found our two algorithms for C1 and C2, right? So if somebody gives us any vector v, we will be able to, in return, give them, using these two equations, we will be able to give them value for C1 and C2 that will give us that vector. So hopefully you enjoyed that video. Hopefully it was a little helpful, and I'll see you guys in the next videos. Bye-bye.